Hi, my name is Chen from University of Michigan in the United States. Today, I would like to present our project that improves crowd testing with structured guidance. So, GUI testing is an important part of software development lifecycle. It helps developers define functionalities and usability defects in the system's front end, creating more robust software. GUI testing requires test cases that consist of a sequence of input events, such as typing a username in the input area and then clicking the login button. And also the output GUI states, such as a model window pop-up. In the rest of this talk, I'm going to call such sequences navigation paths. Ideally, we want the test cases to include as many navigation paths as possible. However, modern user interfaces are frequently complicated, often including many different GUI states, leading to a multitude of possible navigation paths. In practice, there are two major approaches to conducting GUI testing. The first one is to hire a quality assurance team that is dedicated to conducting testing by manually generating test cases on a given GUIs. This approach comes at a high cost. It's not flexible to the developer's team time, and the responses are often delayed. The second approach is using automated tools such as Selenium or machine learning systems to learn the GUI structures. But it requires expertise to develop these techniques and often cannot be adapted to new software. And more importantly, the test cases generated by machines are often not realistic, meaning they don't occur if it's a human operate on the GUI. With the success of paid online crowdsourcing markets, crowd testing becomes a emerging practice. These two screenshots demonstrate the procedure of crowd testing. On the left, it shows a task requester released a task to the crowdsourcing platform, where workers would pick up the task and operate on the given GUIs, and send their testing report back to the requesters. On the right-hand side, it shows an example of the report where it includes the information such as configuration information, navigation steps, error messages, and screenshots. The benefits of crowd testing is that it allows developers to recruit a large number of crowd testers on demand with a low cost to create human-generated test cases. However, crowd testing often results in a high degree of test case duplication because crowd workers tend to navigate the same common path while working in parallel. Prior work focused on analyzing workers' responses to identify and remove duplicates, rather than preventing the issue themselves. Or they would present all the GUI states to guide testers, but it's hardly scalable. For example, Ruda et al. Explored this idea of presenting the screenshots of all different calculator states, and they found that the presentation is time-consuming for testers to understand. So the real challenges are, how do you guide crowd testers to avoid existing test cases, and how do you encourage them to find more test cases? The ultimate goal is to improve the effectiveness of crowd testing by increasing the number of navigation paths that workers can find without compromising time and cost. To address the first challenge, we compared two techniques of guiding the workers to reduce duplication. The first one, on the left-hand side, is showing the textual logs of past user events. And the other one is adding UI overlays that blocks out the regions in the GUI that have previously been explored at a given GUI state. And we also include the baseline condition where users have no guidance. We measured the path duplication rate across conditions and found that with the UI overlays, testers could successfully avoid repeating previous explored navigation paths, but not able to do so with the textual logs or no guidance. And participants report that there were mainly two advantages of having overlay on the UI. First, overlays require less context switching to see which paths were already explored. Second, overlays require less navigation effort when making decisions about which path to explore next. To address the second challenge, we designed an interactive event flow graph, or EFG, to show existing navigation paths as a graph summary. This is an EFG that summarizes all the paths to fulfill a request on the shopping website. By interactive, I mean one can click on any discovered node to directly jump to the corresponding GUI state. This could save users the effort of going to each state one by one, helping them to explore subpaths more easily. Unlike UI overlay, EFG gave people an overview of all the discovered paths, helping them make exploration decisions, not just based on the current state, but from a more holistic point of view. And here is a quick demo of how our system works.
Recruiting crowd testers for GUI testing has become a common practice. However, the testers often navigate commonly used UI paths and then repeat others' results. We introduce techniques to guide testers to find more unique test cases and eliminating duplicates. We do this by showing them event flow graphs that aggregate their interactions into a graph. The graph also augments the UI with CSS overlay to guide testers to avoid duplicates. We showed that these techniques help testers to avoid redundant effort while increasing test coverage by 55%.
So we implemented our techniques as a JavaScript library, which can be instrument to any standard web application. The screenshot on the left shows how one can use it by creating a tracker instance, variable named current active FSM, to listen to events that would happen on the selected widgets. The output of this tracker is an array of JSON objects, which can be used to construct the EFG and display on the testers, to the testers. To find out how effective these two techniques together are on guiding testers, we conducted a between subject experiment. We recruited both trained and untrained testers, 30 in total, to navigate on 11 GUIs. Here's a list of conditions. For example, TB means trained testers in the baseline condition, conducting 11 tasks without the guidance. UG plus means untrained testers conducting the 11 tasks by building on top of someone's responses with the guidance. This is to show that our techniques can support multiple workers to collaborate with each other. The 11 tasks were created by 2 experienced GUI developers, and workers were asked to find all the navigation paths that satisfy a natural language request. For example, purchase 2 toys on this website. We calculated the time span and number of transitions per condition. A transition is the path that can go from one state to another or itself. So in this picture, there are 5 transitions. And here's what we found. The bar chart shows the average transition recall across 4 single tester conditions. The guidance eliminated test case duplication. It also improved trained and untrained testers coverage. And trained testers without the guidance still outperformed untrained testers with the guidance, which means that the guidance can't actually address the lack of expertise or experience. We also compared the time span per condition and found that no statistic difference between within both trained testers condition and untrained tester conditions. We also find that the trained testers can discover new transitions much faster when using the 2 guidance techniques. Both these quantitative results suggest that the guidance did improve the tester's performance on GUI testing. Furthermore, we plotted the usage of the EFG over task time, such as clicking the nodes to jump to the GUI state, and found that it increased throughout the task. Meanwhile, there are new transitions still being discovered towards the end of the task time. This indicates that the guidance can help testers find less common transitions, which helps explain why testers in these groups had higher coverage. Participants also said, the guidance has shaped my testing strategy. For instance, the trained testers said that the interactive EFG helped them remember to avoid the same path and save their time and help them explore the new links. So what can developers use these test cases for? Well, they can conduct user behavior analysis by aggregating the navigation path, or integration testing by integrating each unit graph into the rest of the application graph and then run the join script. And as we mentioned, automated testing tools are good at testing single widget, for example, validating a list of strings for an input box. By combining our techniques with them, developers can prove a more efficient automated testing using these realistic test cases as template. To conclude, this work suggested a new and effective way for future crowd testing. Using our techniques, testers can aware existing navigation paths using the visual cues and easily go back to the previous GUI state to explore different paths using the interactive event flow graph. More broadly, it increases developers' productivity by better coordinating helpers and scaling their effort to increase the responsive quality. Thanks for your attention, and please check out our paper for more details.